Huh?
You know what we're treating today, the topic that we're treating today?
No.
Okay, we're treating how to name organic compounds, particularly hydrocarbons.
Yeah. Okay, sir.
Yes, so let's get into what we have for today. Can you see what's on the screen?
No.
Okay, hold on a minute. How about now?
It's good. Is loading.
Okay, you should be able to see it now. The moment you can
Yes,
see
I
it,
can
let
see.
me know. Okay, what's on the screen?
Nomenclature of hydrocarbons.
Okay, beautiful, beautiful. So we're going to be learning how to name organic compounds. You were in our previous class for SS3, is that correct?
Yes, sir.
Good. So we started off by talking about the introduction to organic compounds. We talked about what organic compounds were, their applications, and all of that. So today we're going to be learning how to name them. And I have some objectives that I want you to be able to achieve by the end of today's class. Can you read them out for me?
Okay. Define nomenclature and explain why it's important in organic chemistry.
Mm-hmm.
State and apply the IUPAC rules for naming hydrocarbons.
Mm-hmm.
Identify the longest carbon chain.
Yes.
I don't know how to pronounce it.
Identify the longest carbon chain in a given structure and name
No,
it correctly.
number four.
Okay, number four, differentiate between number one, alkenes, and alkynes. We're going to be seeing what they are in today's class and then based on their structure and bonding. Are you excited about what we're set to do today?
Yes, sir.
Beautiful. So let's get into what we have for today's class. So first things first, since we're talking about how to name organic compounds, let's define what nomenclature is. Okay, so in chemistry, another word for nomenclature or another word for naming stuff is what we call nomenclature. So when we say we want to name something in chemistry, that word is called nomenclature. Are you there?
Yes, sir.
Good. So nomenclature actually refers to the system of naming chemical compounds in a standardized way. Now, in science, we don't just name stuff arbitrarily. No, there is a particular system that is used whenever we want to name stuff. And that is why all over the world, whatever a chemical compound is called in Nigeria, when you go to the United States of the America, that's the US now, the name does not change. The name remains the same. Why? Because there is a system, a universal system that applies to all locations through which we name
Okay.
organic compounds. So in
Okay,
chemistry,
sir.
especially organic chemistry, it provides a universal language that allows scientists worldwide to clearly identify and communicate about specific compounds without confusion. That is the importance of the nomenclature system. So
Okay, sir.
for hydrocarbons, I have in brackets alkanes, alkenes, and alkynes. We're going to be seeing what they are, okay? So I don't want you to get confused. All right? Nomenclature involves assigning names based on a number of things. First, the number of carbon atoms. Remember, we talked about what organic compounds were in our previous class, and we said organic compounds, or organic chemistry rather, is the study of compounds that contain carbon. Do you remember that?
Yes, sir.
Good. So today, when we're learning how to name organic compounds, there are a number of things you need to pay attention to. You need to pay attention to the number of carbon atoms that are present. And then you need to pay attention to the type of bonds that are also present, whether it's a single bond, a double bond, or even a triple bond. We're going to be learning what all of those things are all about. Okay? So here is the importance of the systematic procedure of naming stuff in chemistry. It is very important because many organic compounds may have common names that vary across regions and cultures. So, for example, now in one state, they might be naming salts, um, sodium chloride, NaCl. You know, you know. And then in another
Yes,
state,
sir.
they might decide that no, we don't want to call it sodium chloride, we want to call it another name. By so doing, there will be confusion everywhere because they have not all agreed on one single name that they want to give to one compound. So that is why this system is very, very important. Are you there?
Yes, sir.
Good. And so that's why we have the system called the International Union of Pure and Applied Chemistry. Have you ever heard this name before? IUPAC.
Yes, sir.
Oh, good. It actually means the International Union of Pure and Applied Chemistry, and they are the ones who created a system. That system is the one through which every compound you see in the world today has one unique and universally accepted name. So this ensures number one, clarity, so that scientists can avoid confusion. So whatever I'm naming a compound, I won't need to be confused when I go to another state or another country. I know that the same name is what that compound is going to bear. And then it also
Okay.
ensures uniformity. Thus far, are there any
Okay.
confusions?
No, sir.
Do you have any question?
Mm. No, sir.
All right, good. So now let's see what hydrocarbons are because in this class we're learning how to name hydrocarbons. So hydrocarbons are actually the combination of two words. What are those two words? You have hydro and then you have carbon. Are you there?
Yes, sir.
Hydro stands for the element called hydrogen. And then carbon, of course, represents the element that is called carbon. Very straightforward. So hydrocarbons are organic compounds made up of only two elements, carbon and hydrogen. Hence the name hydrocarbons. And they are the
Mm-hmm.
simplest form of organic compounds. We have different structures of organic compounds, but the simplest of them all is the one called hydrocarbons. Are you there?
Yes, sir.
Beautiful. And they form the basis of studying other organic substances. So here is an example. You remember we said the organic compounds contain carbon. Is that correct?
Yes, sir.
And carbon has the symbol, a capital letter C. Now, one thing about carbon you must know is that carbon is tetravalent. Let me write out that word. Tetravalent. Tetravalent simply means it has four electrons in its outermost shell. Are you there? Hello, David.
No.
Can you hear me?
Yes, sir.
Okay, good. So one, two, three, four electrons in its outermost shell. Do you know what this means?
Yeah, it has four valence
Good,
electrons.
good. It means that carbon can also form four separate bonds with any element that wants to join with it. And in hydrocarbons, those four bonds are occupied by hydrogen. One, two, three, four. Did you see that?
Yes, sir.
Good. So we're going to be learning how to name stuff like this as we proceed. So What are
Yeah.
hydrocarbons now? Let me refresh your memory a bit. What are
Yes, I
hydrocarbons?
have a quick question.
Okay,
I have a quick question.
yes, go ahead and
What would
ask.
be the name of the element that you just recently drew?
What is the name of what?
The element that you just drew it now,
Okay,
like seeing.
see here,
What's the name of it?
that's carbon.
Yeah. Yes, sir.
Are you there?
Yes, sir.
That's carbon. C stands for carbon.
Okay,
You remember
sir.
we're talking about hydrocarbons and they are elements or they are compounds that are made basically of two elements, carbon and hydrogen. Are you clear now?
Yes, sir.
Good. So hydrocarbons can be classified into three main types based on the type of bonds that occur between the carbon atoms. Let me come again. You remember I told you that carbon is tetravalent. What is the meaning of the word tetravalent?
It has four valence electrons.
Thank you. It has four valent electrons. One, two, three, four. These four valent electrons means it can form four bonds. And usually those bonds can be shared either with hydrogen or it can be shared with even another carbon atom. So this other carbon atom has four valent electrons, one, two, three, and four. It can also share it with hydrogen and it can share it with another carbon atom, and so on and so forth. So, based on the kind of bonds that are occurring between a carbon atom or carbon atoms in a hydrocarbon compound, we have three main classifications of hydrocarbons, and these are them. Class number one is called the alkanes. Can you say that after me?
Well,
The classification of
sour.
hydrocarbons.
Uh, what shall she say?
Hydro, class number one, alkanes.
Okay, saturated hydrocarbons.
Good. So
Contains.
hold on, hold
Okay.
on. I'm not asking you to read it. When I want you to read, I'll let you know. Thus far,
Okay,
do
sir.
you have any confusion thus far?
No.
Okay, good. So the first class of hydrocarbons that we have, based on the bonds that are occurring between the carbon atoms present, is called the alkanes. Now, what is an alkane? An alkane is a type of hydrocarbon that is saturated. They contain only single bonds between carbon atoms. Now, here is what we mean. When you have a carbon atom like this, remember I told you that carbon atoms can occupy four bonds around them. Did you see that?
Yes, sir.
Good. Now, this bond can be shared with another carbon atom. This bond can be shared with another carbon atom.
Okay, sir.
Good. Now, these bonds that you can see over here, all of them are single bonds, are they not? It's just one line that are drawn, that is being drawn, right?
Yes.
Good. Whenever you have a hydrocarbon compound like this that has only single bonds throughout its structure, you call it an alkane.
Okay, sir.
Any confusion?
So, can carbon only go with carbon and hydrogen, or it can go with other elements?
It can go with other elements, but in this case, we're learning how to name hydrocarbons. This is the foundation. This is the basic,
Okay.
or the basics rather. Can you see that? There are cases where carbon, remember, it can occupy four bonds. Is that correct?
Yes, sir.
Carbon can have a double bond joined to another carbon. So in that case, we have one and two. It can only have four bonds. So another carbon can be joined to this, and then you can have another bond over here. But whatever the case is, carbon is not permitted to have more than four bonds occupying it. So here is what I want you to do. For this
Yes,
first
sir.
carbon atom over here, let's count the bonds that are surrounding it. One, two, right?
Okay.
three,
Yes, sir.
and then four. Is that correct?
Three, four. Yes, sir.
How about this carbon atom? How many bonds are surrounding it?
One, two, three, four.
Good, good. So how about this one? How many bonds are surrounding it now?
One,
Good. So how many more bonds does it need?
three.
It needs three more. So I'm so glad that you're getting the hang of what we're doing here. So the first class of hydrocarbons that we have are called what?
Sir.
The first class of hydrocarbons that we have, what are they called?
Alkanes.
Good. And what are alkenes?
Alkanes are saturated
Saturated.
hydrocarbon.
Let me write the definition for you. Alkanes has saturated hydrocarbons having only single bonds between carbon atoms. Can you write that down?
Okay, sir.
I hope you're with your pen and paper.
Yes, sir.
All right, go ahead, write that down. Alkanes are hydrocarbons having only single bonds between the carbon atoms. And while you're writing that down, I want you to write the formula. The formula for alkanes. It is written as CnH2n plus 2. I sent the notes as well to the class. If you downloaded the notes, all of these things are contained there. Did you download the notes? Okay, I just remembered you're not in the SS3 class. Is that correct?
No, sir.
Okay, don't worry, just go ahead and write it anyways. When you're done writing, let me know.
Okay, sir.
Beautiful.
Okay, sir. I'm done.
Beautiful, beautiful, beautiful. So now this is the formula for alkanes. Do you know what this formula means?
Mm, no.
I'm going to tell you what the formula means. The formula is simply telling you that when you know the number of carbon atoms that is present in an alkane, then you can calculate the molecular formula for that alkane. So for example, let's say you have one carbon atom in an alkane. So what this means is CnH2n plus 2. You can calculate the molecular formula. N here stands for the number of carbon atoms. And in this case, we have one carbon atom. Is that correct?
Yes, sir.
Good. So what we're going to have is C. Anywhere we see N, we're going to put 1. So we have 1, right?
Yes, sir.
Good. And then we have H, 2 multiplied by what now?
Sir. H2.
H2,
What?
then N.
Times four.
No. Remember, this is N over
Four.
here. No.
Mm.
What is N?
A number of
And yes, now the number of
uh,
carbon atoms that we have. How many carbon atoms do we have now?
one.
Let's start it again. This is the formula for alkanes. CnH2n plus 2. Can you see it?
Yes, sir.
Beautiful. This formula is telling you that whenever you know the number of carbon atoms that are present in an alkane, you can calculate the molecular formula. You know what molecular formula is, right?
Yes, sir. Heard of
Good,
it.
good, good. For example, the molecular formula for water is H2O. So now, if I now say, David, we have just one carbon atom in an alkane, it simply means that N is equal to 1. So from that information, we can use this formula to calculate the molecular formula for the alkane. How do we do that? We just simply say C, anywhere we see N, we put 1 because that is the number of carbon atoms we have. Do you understand?
Yeah.
So we
Yes,
have
sir.
1, and then we have H, then we have 2 multiplied by what now?
One.
Good. 1, then plus 2. Did you see that?
Yes, sir.
So this will be equal to C1, then H. 2 times 1 is what?
Two.
Plus 2.
4.
Good. So the molecular formula is CH4. Did you see this?
Yes, sir.
Good. So now if we have 3 carbon atoms, what would the molecular formula for the alkane be? Calculate it for me and let me know. Can you do that?
Sir. Sir, if what? I not hear you there.
If the number of carbon atoms are 3, can you hear me now?
Yes, sir.
Good. If the number of carbon atoms are 3, I want you to use this formula for alkenes to calculate what the molecular formula will be. Can you do that?
Yes, sir.
Good. Go ahead. I'm waiting. What would the molecular formula be?
Okay. Carbon, it will be 3, and hydrogen will be 8.
So we have
Sir?
C3 and then H8. Is that correct?
Yes, sir.
Beautiful, beautiful, beautiful. So that's what alkenes are. Now, from that molecular formula, we can actually draw the structure. Did you know that?
Yeah.
C3H8. So we have C bonded to C bonded to C. Did you see how I numbered the carbon atoms? We have 3 carbon atoms. Did you see that?
Yes, sir.
Good. So remember, I told you carbon can take 4 bonds around it. Did you remember that?
Yes, sir.
Good. So let's occupy the whole 4 bonds. One, two, three. This is the fourth one over here, right?
Yes, sir.
And then for the second one, I add my remaining 2 bonds. And then for the third one, I add my remaining 3 bonds. Did you see what I did?
Yes, sir.
Now, the next thing to do is just to add hydrogen atoms everywhere. This is 1, 2. Can you see what I'm doing?
Yes, sir.
3, 4, 5, 6, 7, 8. So if you count
Oh,
the number of carbon atoms, 1, 2, 3, and the number of hydrogen atoms will be 8. Did you see how we drew the structure?
yes, sir.
Is the class boring?
No, sir.
Can we proceed?
Yes, sir.
Good. So that is for alkanes. You've seen what an alkane is. The next one is called the alkenes. Alkenes. Say that after me. Alkenes.
Okay.
Good. What are alkenes? In alkenes, we saw that all the bonds throughout were single bonds, just one line, right?
Yes, sir.
But in alkenes, alkenes are hydrocarbons that contain at least one carbon to carbon double bond. You can see how it was represented here, right?
Yes, sir.
Good. So you can have something like this, carbon joined to another carbon. Then this one can be a double bond. This right here is called an alkene because everything is not a single bond. There is a double bond present. So when a double bond is present in a hydrocarbon, it is called an alkene. Are you there?
Yes, sir.
What is the other name for an alkene? I just labeled it now.
Sir,
The other name for alkenes. What is the other name? I just labeled it now.
alkane,
No, I just
all things,
olefins. Say olefins. That
all
is
things.
good. That is the other name for alkenes. And there is a formula for calculating the molecular formula of alkenes, and that is CnH2n. Can you see it?
Yes, sir.
So, for instance, if I say, David, an alkene has three carbon atoms, can you deduce the molecular formula for me? What would you do?
You NaCN good 3.
Good. So I have C3H2 times what?
3.
Good. So therefore I have C3H6. Did you see that?
Yes, sir.
Good. And then the final class of hydrocarbons that we have is called alkynes. Can you say that after me?
Alkynes.
Good. So what are the three classes of hydrocarbons that we have?
Alkane,
Mm-hmm.
olefins, and alkynes.
Alkanes, alkenes, which is also known as olefins, and then alkynes. I don't want you to forget this classification for as long as you do chemistry. These are the three classes of hydrocarbons that we have. Are you there?
Yes, sir.
Good. So the third category of hydrocarbons that we have, which are called alkynes, are the ones that contain at least one triple bond, one carbon to carbon triple bond. Can you see that?
Yes, sir.
Good. And the general formula is given as what? CnH2n minus 2. So if I say, David, an alkyne has six carbon atoms, what will be the molecular formula? Go ahead and do that for me. Let me see.
Hmm. Okay, I'm done.
Yes, what is the molecular formula?
The answer will be C6,
Mm-hmm.
8, 10.
Good. C6H10. Exactly the same thing with what I got. Thank you very much, David, for following through with all that we are doing in this class. I hope you're getting it.
Yes, sir.
Good. So we have the three categories of hydrocarbons, and we've seen what they are: alkanes, alkenes, and alkynes. So we're going to be learning how to name them. Anywhere you see them, there are certain rules that guide the process of naming them. How do we name them? Are you ready to learn that?
Yes, sir.
Beautiful. So when naming hydrocarbons, we use something that is called the IUPAC rules. What did I call that?
The iPad cruise.
Good. The IUPAC rules are a set of rules and standards that were developed by the International Union of Pure and Applied Chemistry. They set a system of rules that apply to the process of naming organic compounds. Now, these rules are there to ensure that every compound has a unique and a universally accepted name so that we can avoid confusion in communication among scientists worldwide. So let's see what those rules are. Thus far, do you have any question, David?
No, sir.
Are you sure?
No, sir.
Okay, good. So here is step one. Can you read out for me what we have?
Okay, sir. Identify the longest carbon chain,
Mhm.
bracket, parent chain.
Good, good. So whenever you want to name a hydrocarbon, the first thing you are to do is to identify the longest carbon chain. The longest carbon chain in organic chemistry is called the parent chain. Are you there?
Yes, sir.
Good. Remember, I told you that carbon can bond to another carbon atom, which can bond to another carbon atom, right?
Yes, sir.
Good, which can bond to another carbon atom. Now, this is called a carbon chain. And whenever you want to name an organic compound or a hydrocarbon that has this kind of structure, the first step is to identify the longest chain. So to do that, you simply count the number of carbon atoms. And in this case, we have one, two, three, and four. Did you see how I did that?
Yes, sir.
Beautiful. So when you identify the longest chain of carbon atoms, the length of that chain determines the root name. Now, let me show you some examples. When you have a carbon chain that has only one carbon atom, you use the root name METH. This is called meth. Say meth.
Med.
Good. When you have a carbon chain that contains two carbon atoms, you use the root name FETH. Are you there?
Yes, sir.
Beautiful. When you have a carbon chain that contains three carbon atoms, you use the root name PROP. Can you pronounce this for me?
Sir.
Can you pronounce this for me?
Prop.
Good, prop. When you have a carbon chain that contains three carbon atoms. So when it is four, you use the root name BUT, but or but, whichever way you choose to pronounce it. And then when there are five,
Okay.
you use the root name PENT, pent. When there are six, you use the name HEX. Are you there?
Yes, sir.
Good. And when there are seven, you use the root name PHEPT, hept. Are you there?
Yes, sir.
When there are eight, you use the root name OCT, oct. When there are nine, you use the root name NON, non. And when there are 10, you use the root name deca.
Okay, sir.
Any confusion thus far?
Does the name does the name like show what common atoms are there?
Yes, the name is meant to show you how many carbon atoms are there. Like I told you,
Oh,
if the chain contains one carbon atom, you use the name METH, the root name METH. If there are two, this one. So the names there, these names that I just outlined for you, they are telling you the number of carbon atoms that are present. So if, for instance, now you see the name BUT, what is it telling you?
PUT.
Mm-hmm.
Yeah, you have four carbon atoms.
Good. It's telling you that that hydrocarbon, that molecule has four carbon atoms present in its structure. Can you see how the names are important for identifying the structure?
Yes, sir.
So that is the first step. Look for the longest chain of carbon atoms. When you do that, the length of that chain determines its root name. All these names that you just see me underline here, meth, eth, prop, bot, pent, and hex, they are the root names. There are other things you will add to it, and I'll be showing you how to know them as we proceed. But this is just the beginning, okay? The step one for naming hydrocarbons. So you can see this example that I have over here. When you have a chain of six carbon atoms, you use the root name HEX. Did you see that?
Yes, sir.
Good. So step number two, when you have identified the number of carbon atoms, what's the next thing to do? Can you read that for me?
There's number the carbon atoms.
Good. Number the carbon atoms. If there is a substituent, don't worry. I'm going to be explaining what a substituent means, okay? I'm going to explain what a substituent means. If there is a substituent or a multiple bond, you know what a multiple bond is, right?
Yes, sir.
Good. What's a multiple bond?
Multiple bond is something that can like connect with more atoms, carbon atoms.
Okay, okay, nice try. But here in naming hydrocarbons, multiple bond can be a double bond or a triple bond. Remember, I told you that hydrocarbons that have a double bond, what are they called?
So
Hydrocarbons that have a double bond, what are they called?
they are called S.
Hydrocarbons that have a double bond, not two carbon atoms, a double bond, what are they called?
Double, double. They are called E- SETH.
No. Hydrocarbons that have two carbon atoms present, we use the root name ETH. But I told you that hydrocarbons that have a double bond inside their structure, they are called
Oh,
alkenes. Don't you remember?
yes, sir.
Do you remember now?
Yes, sir.
How about hydrocarbons that have a triple bond inside them? What are they called?
Alkynes.
Good, alkynes. Don't get it mixed up, okay? When you have a double bond, alkenes, when you have a triple bond, alkynes, the number of carbon atoms, that one is a different story entirely. If it is one carbon atom, you use the name METH, two carbon atoms, ETH, and so on and so forth. Are you there?
Yes, sir.
Are you confused?
Mm, yes, no, sir. No.
No, no, no. Tell me where you're confused, and we'll go over that again. I'm here to help you understand, okay? Tell me where you're confused.
Uh, Difference of carbon atoms and the multiple bond.
Okay, good. So now, remember we said hydrocarbons are compounds that have two elements, hydrogen and carbon, right?
Yes, sir.
Good. Now, carbon on its own can form bonds with other elements and with itself. So, for example, you can have a carbon atom joining itself to another carbon atom, joining itself to another carbon atom, joining itself to another carbon atom, like this. Can you see this?
Yes, sir.
Good. Now, I want to ask you a question. All the bonds that have been formed so far, as you can see in this structure, are they single bonds? Are they double bonds? Or are they triple bonds?
The for triple bond.
Okay. Now, let me say you're wrong. Why? They are all single bonds because you can see these lines that I drew. They are all one lines.
Okay.
They are all one lines. So now, if I
Uh,
change this from one line now and I change it to two lines, so it means this
S.
compound now has a double bond. Before, when it was only single bonds throughout, I will call this an alkane because it has only single bonds, right?
Sir.
Are you still confused?
No, sir.
Good. But when I now add another bond now, from single it has changed to what?
Double.
It has changed to double. So now that it is double, the name will change from alkane to alkene. Did you see that? Hello, are you there?
Uh, sir.
Hello, can you hear me? Hello, David, can you hear me? Hello, hello. The
So I
number,
can hear you.
how about now? Can you hear me now?
Yes, sir.
Okay, good. The number of carbon atoms that are present in a hydrocarbon. There are names that we use to depict that. And that is where you have names like METH. METH means there are how many carbon atoms?
Sir?
When you hear names like METH, the number of carbon atoms that are present in a hydrocarbon.
One.
Good. When there are two carbon atoms, we use the name what?
ETHS.
Good. Good. Now, regardless of whether it has a double bond, a triple bond, or a single bond, we use the name ETH as far as it has two carbon atoms. Are you there?
Yes, sir.
Are you still confused?
No, sir.
Don't worry. We're going to treat some examples and then you see how it plays out, okay? Rule number 3. Read that.
Okay. Locate and name substituents. Alkyl group.
Alkyl groups, okay? So I'm going to be showing you what substituents are. Don't worry, don't get confused about anything, okay? Even me, when I was learning this thing for the first time, it seemed a bit confusing to me. When we treat the examples, you would see what it means. So substituents, just know this, they are the branches or side groups attached to the parent chain. Okay?
Yes, sir.
Good. And then step number 4, position of the multiple bonds, whether double or triple. If the chain contains a double bond, it is named with the suffix ene. Did you see this?
Yes, sir.
Good. So here is what we mean. For instance, if a hydrocarbon has one, two, three, four carbon atoms, what parent name are we going to use?
Uh, but
Thank you very much. BUT. So if it has a double bond inside its structure over here, this rule is telling us that if it contains a double bond, we are going to add the suffix ene to it. So we are going to say but plus ene. Altogether, what are we going to have as the total name?
but thin.
You call it butene. Did you see how I named it?
Yes, sir.
Good. So as we treat more examples, you're going to be seeing how it plays out, okay? I don't want you to get confused. So let's talk about the nomenclature of alkanes. Remember, we talked about the categories of hydrocarbons. We said there are alkanes, there are alkenes, and there are
Okay.
good. So we want to start with the first category, naming of alkanes. Are you ready?
Mm,
Are you sure?
yes, sir.
Or should we end the class here?
Yes, sir.
We should end the class here.
No, sir. No, that's not it here.
Okay. So here is the first class of alkanes that we have. We call it the straight chain alkanes. When they say something is straight, what do they mean?
Uh, is it's not bent.
Thank you very much. It is not bent. It's just going in a forward direction. No movement to the sides, no movement to any of the sides, just moving forward. Are you there?
Yes, sir.
Good. So when you have a straight chain alkane, they are the simplest type. What we mean by straight chain means the carbon atoms are just arranged in a single file, carbon to carbon to carbon to carbon. No bending to the left or to the right. Did you see that?
Yes, sir.
So when carbon atoms are joined in a continuous, unbent, or unbranched chain, their names end with the suffix ane. This ane is pronounced as ane. Pronounce it after me, ane.
Me.
Good. So here are the common examples that we have. We have the first example, CH4. This is what the structure looks like. One, two, three, four. Did you see how I drew the structure?
Yes, sir.
Good. So when we want to name this, rule number one says identify the number of carbon atoms that are present. How many carbon atoms are present in this molecule right now?
Sir.
How many carbon atoms are present in this molecule?
One.
Good. So when you have one carbon atom, what is the parent name that you will use?
Sir.
When you have one carbon atom, what parent name do you use?
Mhm. Meth.
Thank you very much.
No.
METH. Meth, telling us that there is one carbon atom. Now, the next question you will ask yourself is this an alkene, or an alkyne? Which of them is it?
Okay.
Which of them? The first or the second one or the third one?
First. First.
The first one, it's an alkane because only single bonds are present. And all alkanes end with the suffix ane. So I'm going to come here. I have my parent name meth, and then I'll say plus the suffix, which is ane. What would the total name now be?
Sir.
What would the complete name now be?
Methane.
Thank you very much. Methane. Methane. Did you see how I named it?
Yes, sir.
Good. So now, David, I want you to name this next compound for me. David, can you name this for me? Hello, David, are you there?
Yes, sir.
Yes, go ahead. Can you name this for me?
Okay, sir. Try.
Yes, go ahead, go ahead, go ahead.
Okay. 19. I think it. So, okay, I know it's C6H14, but uh,
Go ahead. Name me whatever name you come up with. Let me know. I'll let you know if you're correct or wrong.
pentane.
Okay. Thank you for trying, but you are wrong.
Okay.
Just hold on. Let me get a glass of water to drink, okay? Don't go anywhere.
Okay, sir. Okay, sir.
All right, Dave, I'm back. Are you there?
So,
All right, good. So, first, I want to say thank you for giving it a try, okay? But let me show you where your mistake came in. When you want to name an alkene, the first thing to do is to count the number of carbon atoms. So, can we count together?
okay, so
Okay, so we have one,
1, 2, 3,
5, 6.
6,
How many carbon atoms?
6.
Good. Let's write that down, 6. When we have 6 carbon atoms present in an alkane, what is the root or the parent name that we use? Did you write it in your
6,
notes? Did you write it in your notes?
6. Yes, yes, I
Okay, so check your notes. What parent name do you use for 6 carbon atoms?
use hex.
Hex.
Yeah,
Then we put plus. The next thing to ask is this an alkane, an alkene, or an alkyne?
alkyne.
I want you to think again. Is it an alkane, an alkene, or an alkyne? Which one?
Uh, uh,
To know if it is an alkane, to know if it is an alkene, or to know if it is an alkyne, the first question you need to ask yourself is, what kind of bonds are there? Is it single bond? Is it double bond or triple bond? What kind of bonds are present in this molecule, David?
triple bond.
Single bonds, good. So if it's single bond, is it alkane, alkene, or alkyne?
Yes. Alkane. Yes.
Good. So if it is an alkane, remember we told you that the suffix will end with what?
So we end with in.
Ane, A-N-E. So we have hex, which is the parent name, plus the suffix A-N-E. So what is the complete name going to be?
Hex in.
Hexane. Thank you very much. Did you see how we named it?
Yes, sir.
Okay, let me give you another example to do. 1, 2, 3, 4, 5, 6, 7. Can you see what I'm drawing on the screen?
Yes, sir.
Okay, good. I want you to name this for me, David.
Uh, Heptane,
What did you call
sir.
it?
Heptane.
Heptane. Thank you very much. This is beautiful. You got it correct. Oh, yeah, give yourself a round of applause. Clap, let me hear you now. Ah, David, you can't clap again. Hello, David, are you there? Hello, David, are you there?
Yes, sir.
I say clap for yourself.
Yes, sir.
Clap for yourself. Let me hear you.
I did.
Hello, David.
Yes, sir.
Have you clapped for yourself?
Yes, sir.
How come I didn't hear you clapping for yourself?
Uh,
All right, there's
uh,
no problem. Let's proceed. Can you read what's on the screen right now?
yes, sir.
Oh, yeah, read it.
Branched chain alkanes. When the main chain of carbon has one or more branches, bracket side groups, we name them as follows. Identify the longest continuous chain as the parent chain. Name the side chain, bracket substituents, as alkyl, alkyl groups, bracket, bracket minus
Not
CH3
minus.
equals
Okay,
to,
that's not a minus. Okay, that's just CH3. Okay, I'll explain what
uh,
that
uh,
means. CH3 is called methyl. C2H5 is called ethyl. And then so on and so forth. Don't worry, I'll explain what all of that means, okay? Now, I want you to listen. The examples that we just treated, naming some alkanes, you would notice that it was just a straight chain. Carbon joining to carbon, joining to carbon, joining to carbon. Is that correct?
yes,
Good. Now, there are some cases where the chain will not be straight throughout. There is a part of it that can bend. For instance, it can be like this, and then over here you have 1, 2. So can you see that the chain is no
yes,
longer straight?
yes, sir.
Good. The chain has bent. So in that case now, when you want to name this compound, when you have counted the longest continuous chain, anyone that is not part of it, for instance, if this is my longest chain, 1, 2, 3, 4, anyone that is not part of it now becomes a substituent or a branch. What did I say?
Any one of this we call a substituent or a branch.
Good. So when naming hydrocarbons, anything that is not part of the parent chain, it becomes a substituent. A substituent is also called a branch. So I want you to label for me which part now is the branch.
Uh, a upper part,
Good.
like
This
one
part,
going up.
good. This part now becomes the branch automatically. Did you see that?
Yes, sir.
Very good. So now we have different types of branches when we are naming alkanes. When it is just one carbon atom that is forming the branch, we use the name methyl. Did you see that?
Yes, sir.
When we have two carbon atoms forming the branch, we use the name ethyl. So in this case now, how many carbon atoms are forming the branch?
Uh, True.
Good. So the name we're going to use for this branch is called ethyl. Did you see that?
Yes, sir.
If there were three carbon atoms forming the branch, we use the name propyl. Okay? So now we're going to treat
Yes,
some
sir.
examples and then we'll call it a day from here. Can we treat some examples?
Yes, sir.
So here is the first example on the screen. Let me redraw this in a way that you can see. We have C, one, two, three. That's CH3. Then bonded to another C.
Mhm.
David, can you see what's on the screen?
Yes, sir.
Are you sure?
Yes, sir.
Good. So now let's follow the rules. Rule number one, identify the longest carbon chain. Can we do that now?
Yes, sir.
All right. What is the longest carbon chain?
Uh, that's four. That's both
Okay, how did you arrive at both?
because there are four carbons different.
You are correct. There are four carbon atoms, but I want you to watch this. When we want to count the carbon chain, we go in a straight line that doesn't go backwards or upwards. Now look at this. If I want to start counting from this point over here, I can say one, two, three. After counting three, I cannot come here and say four. No, that will be disobeying the rule.
Oh,
The longest continuous carbon chain, take note of that word, continuous. Okay? So if I'm starting from here now, one, two, three, I cannot come here and now say four. No, that would be disrupting the rule. Did you get that?
yes, sir.
Are you sure you did?
Yes, sir.
Good. Let me show you another way I can count. I can also count like this. One, two, three. I can follow this direction. Did you see that?
Mm-hmm.
I
Yes,
can
sir.
also follow this
I cannot
direction.
go back there.
Yes, once the arrow, any arrow that
Yes.
I'm going in a forward direction. I cannot go back down again. Or once I'm here, I cannot come down again and say I want to start counting like this. No. Did you see what I did?
Mm-hmm.
So let's count our number of carbon atoms now. I can start counting from here. One, two, three. So how many carbon atoms do I have?
Yeah, three.
Good. In the parent chain, I have three carbon atoms. Okay? How many carbon atoms do I have in the parent chain?
I have three.
Three carbon atoms. When we have three carbon atoms in the parent chain, what is the root name we use?
Real crop.
Thank you very much. We use prop, P-R-O-P. Did you see that?
Yes, sir.
But we are not done. We are not done. The next thing to ask yourself is there any branch? Is there any branch in this compound?
Yes, sir.
Good. Where is the branch?
Is you see going upwards.
Thank you. This guy over here going upwards. is the branch. So now let's identify our branch. Our branch is CH3. What is the name for CH3 when it is the branch?
Uh, uh, I, I don't ask my question.
Okay. I was asking, what is there any branch in this compound? Is there any branch?
No.
Are you sure? We have counted. Remember, I told you when you have the parent chain, and this is our parent chain here, right?
Yes, sir.
Good. And we've counted our parent chain to have three carbon atoms. And we said when there are three carbon atoms, we use the root name prop, right?
Yes, sir.
Good. Now, and I told you that anything that is not part of the parent chain becomes a branch automatically. Do you remember that?
Yes, sir.
Good. So is there any branch in this compound now? Look and tell me.
Yes, sir.
Good. Where is the branch?
Branches is CH3.
Good. This one over here, right?
Yes, sir.
Good. That is the branch. Now, there are different names that we can give to branches. And I showed you in the previous slide. Can you see this?
Yes, sir.
When it is CH3, what name do we call it?
Methane.
Methyl. So in this case now,
Methyl.
yes, in this case now, what branch do we have in this compound?
Methyl.
Good. We have CH3, which is this branch over here. So we call it methyl. Did you see that?
Okay. Yes, sir.
Are you sure you understood what I just did?
Yes, sir.
Good. So now that we have named the branch, the next thing to do is to identify the location of the branch. So look at step number one. Identify the longest carbon chain. Have we done that?
Yes, sir.
How many carbon atoms are there in the parent chain?
3.
Good. And we
Pro.
have probe. Thank you. Then step number two, number the carbon atoms. Have we numbered them?
Yes, sir.
Good. Then step number three, locate and name substituents. Have we done that?
Mm, yes, sir.
Yes, that was where we got this methyl from, right?
Yes, sir.
And then step number four, position of multiple bonds. Are there any multiple bonds in this compound?
No.
Good. So we skip that part. And then the step number five, combine the name. So now here is how we do the name. We have the prefix and then the parent's name and then the suffix. The prefix, how do we get the prefix? We put the number where the substituent is attached to. What do I mean? This is the branch over here or the substituent, right?
Yes, sir.
Good. What number is it on? Look at our numbering. We have 1, 2, 3. So what carbon atom is it on? Is it on carbon number 1, carbon number 2, or on carbon number 3?
Number 1.
Look at it again. Is it on carbon number 1, carbon number 2, or carbon number 3?
Number 2.
Carbon number 2. So it's on carbon number 2. We put the number 2. What is the name of the branch?
The berry.
The branch. What's the name
Berry.
of the branch?
Oh, methyl.
So we have 2-methyl. We have identified the name of the branch, 2-methyl. Methyl is the name of the branch, and 2 is telling us that it is on carbon number 2. Are you there?
Yes, sir.
Good. So now what is the parent name of this compound? The parent name is the number of carbon atoms that are present in the parent chain.
Yes, sir.
So what is the parent name now? How many carbon atoms are there?
3.
Good. So what is the parent name?
Everything's prop.
Okay. And then I have, is this an alkene, or an alkyne?
Okay.
Good. So the suffix now becomes "-ine". So what I'm going to do is I'm going to add all of these together. So I have 2-methyl propane. Did you see that?
Yes, sir.
Don't worry, Dave. I know this is your first time, so I'm not expecting you to get everything A to Z. I want you to go and do these ones as assignments for me. I want you to go and name these compounds. Can I draw them on the screen for you?
Yes, sir.
Okay, so number 1, write them down as I'm writing them.
Okay.
So I want you to name all these compounds for me, 1 to 4. Okay?
Okay, sir.
I'll drop the link for doing that assignment on the screen, and then you let me know what the names are. All right?
Okay, sir.
Don't worry, I know
So,
this is
sir,
your first. Huh?
I'm still writing.
Yeah, yeah, go ahead, go ahead. Write them down.
It's not done.
All right, beautiful. So I'll drop the link for the submission of this assignment on the SS3 group. Are you on the SS3 group?
Just joined.
Okay, I'm going to drop it then, and then you'll be able to submit the assignment, all right? All
Sir.
right, so today we'll call it a day. I think you've done enough. Thank you for tuning in for today's class. Up until next time, all right?
Okay, sir.
All right, bye for now.
Mhm.